Let's welcome Jeremy Foote to our CCSE research workshop on social media strategy in the C-SPAN Video Library. He's an assistant professor of communication with an expert in network analysis. And he's going to show us examples of how the data from the C-SPAN Video Library could be used to identify influential individuals, and just give us a teaser about what network analysis can do in the video library. So Jeremy, why don't you take it from here?
So I am Robert said, a faculty member in the Lamb School of Communication here at Purdue, also a member of the Community Data Science Collective. My plan for today, what I hope to get out of today's session is one, a kind of a brief overview of what social network analysis is. I have made very few assumptions about sort of people's background or expertise, and so I'll start pretty basic. A provocation of how C-SPAN data might be used to do network analysis with through the lens of a hypothetical project of identifying influential senators. But I am admittedly pretty new to the C-SPAN archives. I feel like I have a decent beginner sense of what's available, and so I really want to have a discussion about other ideas, or sort of use this as a way of prompting a way of thinking about how a network approach might be useful for understanding this really rich, wonderful set of data, and with the hope that others will kind of go farther, and we might have a conversation about what could be done. So to begin with, what is social network analysis? My definition is that it's a set of methods and theories that are focused on this idea that the who we're connected to is often more important than who we are. And so this is very related to ideas from sociology, which is where a lot of social network analysis was originally developed, that we are embedded in kind of a larger social structure. And so this is a way of measuring that social structure and thinking about the ways that it can impact and influence us. So social network analysis, you've probably seen figures like the one here. It's a subset of network analysis. So if we think, I don't know if you can see my mouse, but each of these circles represents an entity, a node, is the term we usually use, but an agent, like something. In social network analysis, this is almost always people, but it could represent, for example, power plants, and these edges, or the lines between them, represent some sort of relationship between the entities. So it might represent power plants and power lines that connect them, or airports and flights that go between them. In social network analysis, almost always the circles represent nodes, and the lines, or the edges, represent some sort of relationship between the people. So this is a very famous social network graph. It's one of the earliest. It is a network of karate students in a karate club. This is friendships outside of the club. So what was actually measured, these edges represent someone that you spend time with outside of karate. And so, for example, this green node at the top and this purple node, that edge between them means that outside of karate, they spend time together. In the original use of this network approach, the researcher, there was a split or a schism where one of the members of the club decided to, I think it was, start their own club, and they used this, again, without any information about the nodes, to predict who would join each group. And you can kind of already see that we would predict, right, that there'd be sort of a split right here, that the people on the left would be part of this group and the people on the right might be part of that group. And so again, this is independent of knowing any information about the nodes, nothing about how long they'd been in the club, nothing about their gender or their age or any other attribute that we might, otherwise use to think about, how they might make these decisions. But only knowing about their structure and how they're connected to each other, we can do things like predicting, how a group will split. And there are a number of other things that we can use network analysis or the theories and methods of social network analysis to predict. So, for example, predicting something like when people are likely to become friends. This image represents a concept called triadic closure. So if we think about person A here, who has friends B and C, we would predict that in the future, B and C would also be likely to become friends. Much more than, it'd be much more likely than, for example, B becoming friends with another random person, D, who is not connected to either A or C. This, we can think of a lot of mechanisms, a lot of reasons this might happen. For example, if A and B spend time together and A and C spend time together, then that means that B and C are much more likely to interact and to meet each other, which is sort of a prerequisite for becoming friends. If A and B are friends because they're similar to each other, have similar interests and values, and A and C are friends because they have similar interests and values, then again, we might think that B and C would have similar interests and values and therefore more likely to become friends. This is an idea called homophily. But whatever the mechanism, knowing just something about the structure can help us to predict what will happen in the future and how people will behave. Another version, another kind of theory from social network analysis and from the early days of social network analysis is called balance theory. So we can predict when people will like each other and how those relationships might change. So we can think of edges as having not just representing friendship, but having a valence where friendship is positive and dislike is negative. So if we imagine in this first one that Tom, Joe, and Tina all like each other, they're all friends with each other, that is a network that's in balance. And so this theory says that a network that is balanced is likely to persist in its current state, and a network that's unbalanced is likely to change so that it becomes balanced. And so if we think of everyone liking each other, then that's all balanced, right? Everyone is friends. This is just a friend group. Similarly, another balanced network occurs when this is sort of the idea. So Tina is disliked by both Joe and Tom, but they like each other. So that's also in balance. So this is the idea that the enemy of my enemy is my friend, or in other words, the enemy of my friend is my enemy. So either of those are balanced. So for example, Tina dislikes, or Joe dislikes Tina and likes Tom. You can think of lots of reasons that Tom might want or learn to dislike Tina. But unbalanced networks are likely to change. And so if, on the other hand, Joe is friends with Tina and Tom is friends with Tina, but Joe and Tom hate each other, then something has to give, something will change. That either Joe and Tom will realize, oh, the other one is not so bad, and they'll become friends with each other, because Tina is always talking about how great they are, or on the other hand, if this dislike is so strong, then Tina will not be able to persist in friendship with one of the others, right? That she will begin to dislike them due to that imbalance. And finally, when everyone dislikes each other, this is a little bit weaker form, but when everyone dislikes each other, you can imagine that you become sort of the enemy of my enemy becomes my friend, right? If Tina dislikes Joe and Joe dislikes Tom, then we can think that Tina and Tom might eventually come to like each other a little bit more. So that's again another idea of how we can predict just using structure, just using information about the relationships and nothing about the people themselves to predict what they will do. One kind of final example along these veins is the idea that we can predict beliefs, that there is a set of tools or a set of theories and methods that try to measure influence and how influence spreads throughout a network. And this concept of social influence says that our beliefs will become similar to those of our friends. So this example, this is sort of a screenshot from Nikki Case's Wisdom and Madness of Crowds simulation, which is really great. It's definitely worth playing around with. In this simulation, we imagine that people, imagine that this person, this blue node, has some behavior that they are, or belief, or even mood we could think might travel through social influence, that they are altruistic, for example, that they have altruistic tendencies, and that is something that's contagious, that can spread. And so in the simulation, we imagine that it can spread to those who at least 25% of your friends have this, altruism altruism activity, then you will gain it as well. That's what this black line represents. And so at first, it's just this first node, and then we could predict where it would spread next and the speed at which it would spread. So at the next time step, these three nodes also are the same, and at the following time step, the last two will. So we might also be able to predict, where and when things won't spread. This sort of analysis can do things like identifying when echo chambers are likely to persist, or how different, like conspiratorial thinking can spread and exist in a network without being disrupted by media or by other things that might, by the truth, really. So those are kind of three sort of ways that social network analysis has been used in the past. The one that I want to focus on, and that I'll use as a motivating example for the C-SPAN data, is that we can also say things about the individuals in the network based on where they appear. So there's this concept called centrality. There are a number of different ways to measure centrality. This network, I've colored the nodes in the karate network based on eigenvector centrality. We can think of a few different very simple measures of centrality. One is just how many friends you are. This is sometimes called popularity, or degree centrality. So the degree is the number of edges, the number of friends, and all else being equal, we would think that those with the most friends would have the most influence. This is closely tied to concepts like social capital. So people with high centrality and high social capital are able to spread their ideas. Research shows that they're, in a business context, they're the ones most likely to get promoted, have their ideas adopted, etc. And so we would predict, for example, in this network, that those with these, high eigenvector centrality would be the most influential. And so we might think, for example, this node in the middle is, has a moderate number of friends, but high eigenvector centrality, because it's sort of in between other nodes that are also powerful. And so, yeah, through these network measures, again, knowing nothing about the nodes themselves, right? We don't have measures of charisma or how often they are listened to, or who looks up to them, or anything like that. We only know who they're connected to, and through that we can identify or predict things about their influence. So how might we use that with the C-SPAN archive data? So what I want to do is sort of go through how you might do this with the C-SPAN archive data. As I'll explain in a minute, I was not able to use actual data for this. It is only hypothetical, but I'll talk about sort of some of the limitations and the ways that you might do this, and kind of what is needed before you could actually undertake this. So, for example, imagine that you had this goal of identifying politicians that were central to the discussions about a topic. So, for example, you might identify those who are the key players in climate change. And we can think of lots of reasons we might want to do this. A politician might want to point to their ability to enact, or their role as a powerful player. We may also want to compare their promises to help on an issue with what actually happens and how powerful they really are. Lobbyists as well, obviously, might be interested in this information. So what might we do if we wanted to figure out which politicians were central to climate change? So first, we would want to identify the hearings about a topic. Second, to gather data about which senators participated in which hearings. Third, we create a senator to hearing network, and I'll kind of show each of these steps and how it would work. And then fourth, we would identify the senators with the highest centrality, the highest social capital in that network. So in order to do this, really what you need is access to the C-SPAN Archives API. And again, I will make very few assumptions about how familiar people are with the API or APIs in general. So an API is, or an application programming interface, lets programmers get information from a server sort of independent of the, without going through a web browser. In other words, they use a program to get information or data from a server. The C-SPAN Archives has a lot of interfaces of APIs to get information mostly about its programs. There is also an API about bills that have been sponsored, but also people who have been on C-SPAN programs. So there's a bunch of named people and information about them. The programs themselves, information about when they aired, what the title was, that sort of thing, as well as search and pretty powerful search for words or phrases that appear both within programs, in program titles, etc. And so you can see where this is going. You could use the search API to look for programs that include the term climate, for example, either in the text or in the title of it. And you would get back something that looks sort of like this. So this is actually a real response. This is called JSON. It is you can tell it is not made for humans to read, but it is, they still call it, human readable, because it is, you can see the words here. You can actually, parse it. If you've read it a little bit, you can figure out what's going on here if you kind of know what to look for. And so what this is that there are two programs. This is just the beginning. There were, actually dozens when I searched for hearings about climate. And so this first one is, we can see the title of the program was Global U.S. Climate Change Policy and Strategy. The description is 2 subcommittees of the Senate Foreign Affairs Committee held a joint hearing on examining the United States global climate change policy and strategy. So it says what date it was, and then a link to the actual video itself. And importantly, an ID. So each program has an ID. And you can use that ID to then look up more information about it, make sure it's the type of video that you think it is, etc. So that's the initial search API. And I don't know, I'm also happy to sort of, pause if there are any questions, or at any time, if folks have questions, please, stop me and ask. I'm very, very happy to pause at any time, and I'll just sort of look to Robert for cues that there are questions out there. But I'll carry on. So that's the initial step, right? So we might identify a set of programs that are relevant. This step, typically, at this point in a computational project, we would do one of two things. Ideally, in this case, if we're looking just at Senate hearings, we might get back 50 results, something like that. So it's something small enough that a human could go in, the researcher would go in and identifying those that are actually relevant, and maybe removing some that are not relevant. Or maybe, you can come up with a few queries or expanding your queries until you feel like you have a pretty good set of the relevant programs. For a larger set of topics, for example, maybe you want to look at all of the C-SPAN programs about climate, over the last 10 years. This might be really difficult to do, just to manually examine each of them. So, you might examine a subset, figure out some ways of filtering those down. But in our case, it's doable. So imagine we've identified the programs. The next step is to identify the people involved. So this is the part where the C-SPAN API, as of right now, is not quite ready to do this in an easy way. At least there might be a way to do this, but I'll talk in a second about that. So what we would want ideally is something like this, where we have this. You'll note, there's no way you'll remember, but this is the same ID that I had before. So ideally we would have an API where we could give the ID, we kind of make a list of all the IDs that we had collected for the programs we wanted to get information about. We take the ID, send it to the API as a request, and then get back. So again, this is the same title, Global US Climate Change Policy and Strategy, same description, but as part of this additional information, the participants. So I have made up this line. I've talked with the folks at the C-SPAN archives. They're really open on their roadmap is adding something like this. And it probably almost certainly will not look exactly like this, but adding something like this is on the roadmap. But you'll need you'd want something like this. So this is kind of the simplest version. We have participants, and so I'm looking at this row here. And so this is just a list of participants, right? So we have the name of each participant and the ID of the participant. And then so we have Christopher Coons and Mitt Romney were the two participants in this, made up version of this program. So we have, again, additional information about the image associated with it, the date, et cetera. Yeah, Robert.
Now, wouldn't you need, I was thinking of the database, and we have a particular hearing and say 10 senators show up, but don't you need each senator when they speak, like you might need 100 observations as opposed to 10 observations?
That's a great question. Yeah, so speaking with the developers, I think that would be the ideal data, because then you could do some more sophisticated things about understanding. For example, if someone just spoke for 30 seconds, you might not want to include them at all, or you could do networks of who spoke after who and things like that. There is still a technique, which I'll show in just a second, which only involves knowing who participated at all in a hearing.
Okay.
So even if that's all we got, there are still some techniques that I think would still be useful.
Okay, thank you.
Yeah, thank you. So in this case, imagine that all we have is who participated. So what we would do is build this senator to hearing network. So this is called a bipartite network. And again, I realize I'm throwing a lot of terms out there from social network analysis, but we would create what's called an edge list. So I talked about how a link between two nodes is called an edge. So an edge list, as you can imagine, is a list of edges. And so this is the list of, here's an example of what this might look like. For each person who is at a hearing, we create an edge from them to the hearing. And so on the left side, we have, the name of the hearing, and then a comma separating it from the person who is there. And so, we would, for each hearing, you'd have a kind of, the hearing would be listed over and over again. And then for each person that was there, they would be on the right side. I'll show you again what this might look like. As I mentioned, there's lots of ways you could make this more complicated. You might only include those who spoke for at least X minutes, or those who are, central to the hearing, the top 5 participants or something like that. But no matter how you, constructed this edge list, you would end up with something sort of like this. So this is again, a random made up data of a bipartite network of what it might look like. So we have hearings on the left and then senators on the right. And so an edge between them means that senator participated in that hearing. So for example, the very top hearing, only the 4th senator was the only senator that participated, whereas the second one down, it looks like there are 1, 2, 3, 4 senators that participated in that one, et cetera. And similarly, this 4th senator participated in 2 hearings, whereas a few of them down here, it looks like participated in 3 or 4 of the hearings. And so that's the idea. That's the first step, is we build this bipartite, and it's called bipartite because there are 2 types of nodes that can be connected. One node can be connected to the other node type, but they can't be connected to each other. So a senator can't be connected to a senator, a hearing can't be connected to a hearing, because what the edge represents is participation in a hearing, the senator participating in a hearing. That's what we start with. yeah, questions about that part. This is kind of a pretty important conceptual piece. Okay, so what we do next is we project, it's called, the bipartite network to a one-mode network. And what that means is that we change what the meaning of the edge is. So instead of an edge meaning that, connecting to a senator and a hearing, we now connect the senators based on the number of hearings that they attended together. And so if two senators are connected in this new graph, it means that they attended at least one hearing together. And again, you can imagine complicating things. I'll show you the graph in just a second. In fact, I'll just show it to you now. We could, for example, have the width of the edges change based on the number of hearings that they attended together. Or something like that. There are a number of things, or we only include it if they attended at least two together. Or if they, or the width could be how much they spoke total or spoke together. But here's the simplest version where an edge just represents that they attended at least one hearing together. Again, this is made up data. This is not a real analysis, but in this made up version of climate change policy, we could identify, for example, Dick Durbin as the kind of most central, most influential person in this climate change topic, based on the things that they had participated in. So again, you can imagine a lot of different types of information that a graph like this can give you. Number one is what I've said already, which is an argument that this can help you identify the most powerful people, the people whose opinion matters the most, I guess, and who we would expect might have influence in this network, those whose ideas are most likely to spread. We could also, at this time of intense polarization, look for people who are bridging parties. In this made-up network, based on the way that I constructed the data, everyone is sort of in one big group. But I would imagine that for lots of topics, we might see two different, or maybe three different communities of people who are talking to each other, but not to the other group. And so identifying people who bridge divides, I think, is really valuable right now. And then also looking for, we can think of not only at the individual level, but thinking at the topic level and thinking about ways for patterns in how different topics are organized. That looking for ones where there's a lot of consensus versus ones where there are groups and where there's bifurcation, where there's centralization, for example, where one or a few people have lots of power and lots of people on the periphery, or topics where there's lots of the power is spread more evenly. So you can imagine lots of different analyses, even just around this idea of identifying influential topics. Obviously, this is just one kind of cherry-picked version of what a network approach might look like. I think that there are lots and lots and lots of different things that you could do with the C-SPAN archives. It's really, really rich data. The fact that we have not only the programs themselves, but the closed caption, text for so many of them. I mean, you could do things like building networks based on which senators mention which other senators in their speeches, right? And thinking about how that relates to, and maybe even tying that to like a sentiment analyzer and figuring out whether people are mentioned in positive ways or negative ways, and sort of build a network of respect or a network of disdain based on how people are mentioned, right? And figuring out who is central in those networks. That you could do things like community detection. And so again, depending on how you build these relationships, but even within a topic, for example, you could imagine in this topic that I had that we might detect that there are different people who participate in different types of hearings. And so a network approach could do community detection where it says, like, these people are in one community, these people are in another community. And then you might combine text and networks to look at that. So for example, you might look at how different, how words are used differently, or framed, how the concept is, or the topic is framed differently by each group based on who the nodes are that are in the group, right? You could do some computational text analysis of the words that are used and how they differ between the groups and how they're talking about a topic. We might compare as well features of the different groups, of the people within them, etc. We might also use networks to predict, for example, which bills get passed. We could build some sort of classifier that looks at how a bill gets discussed and what the network of discussion looks like for a bill, and use that to predict whether or not it will be successful. For example, even maybe in committee, etc., and use that to predict which bills get passed. Again, I think we're very quickly running into the edge of my expertise on C-SPAN and on politics, but I think that the ideas of networks, the idea that we can think about, not just in sequences and not just in individuals, but thinking about relationships between people, and how we might use those to see the world differently, I think is really powerful. I hope it's been a little bit of a provocation to you. So I look forward to chatting about this now, to continuing conversations. Please feel free to reach out, and thank you again for inviting me.
Very good, very good. That's a good introduction, both to social network analysis, but also to how it could be used. So let me just follow up on this Senate committee. We know that some senators just pop in and ask their question and pop out. And someone would say, well, they might have less influence if they're not there the whole time. So if we measured the amount of time that someone was speaking total, so the chairperson might have spoken, 45 minutes in total, and the other person spoke 5 minutes. Is there anything you could do with that?
Yeah, so there is. I mean, there are people. So we would think of that as a weight. So like how strong is the connection, in other words, between the senator and the hearing? You might think that the more someone speaks, the stronger the connection is. And so there's a few things you could do. The very simplest is to just say, okay, anyone that spoke under 2 minutes, we just aren't going to include them. But there are some more complex things that people do that basically sort of try to take that weight into account in some way when you're figuring out who's central. When you're doing the math for figuring out which nodes are most important, you include the weight as part of that calculation. And there are lots of different complicated ways to do that. But the short answer is there are folks who are working on figuring out good ways to do that.
Okay, good. That's good. Anyone here have other questions? I don't want to dominate here, but I'm fascinated by this area. Well, tell us what kind of software should one look for? Setting aside that, let's say you found the data, you got all the C-SPAN data, but you want to analyze it into those pretty pictures.
Yeah, that's a great question. So I can tell you what I use, which is iGraph. It's in R. So there are the most powerful, for sure, network software is in programming languages. So both Python and R have really great tools for it. There are a few others. So UCINet is a fairly old programming language, but it does the job. Or sorry, an old software. It's more point and click. You could definitely do that with the C-SPAN data. Another option is called Gephi, Gephi. It is more of a visualization, and so you wouldn't be able to. It doesn't really do the network statistics, but making a really nice, beautiful picture of what you've done. It's really nice for that. And there are a few others. I know there's some more visualization ones that have sort of come online more recently, but I don't remember off the top of my head.
Okay, all right. So that's the next step. You mentioned that just in passing, there are statistical analysis then to measure whether one edge, say, is more powerful than another?
Yeah, so there are a few different approaches. So one, like there are a few things that you might do. So one is that if you wanted to, for example, build a classifier looking at whether a bill gets passed based on the conversation that happens around it, then you might summarize the conversation for each bill using some measures and use, something like regression to predict whether it gets passed. And so you might measure, for example, the centralization of the network, which is how it's sort of the standard deviation of the centrality of each node. So is it that one node is way more powerful than the rest, or are they all kind of equal in the way that they're speaking? I mean, you might pair this with other measures of the text itself, right? Was there animosity? Was there, you could use computational text to look at the sentiment of the conversations, et cetera. And so you might do things like that. But yeah, so I'm thinking centralization. There's a measure called hierarchy that sort of looks at is there turn taking? Do people, follow each other, or is it just sort of one person who speaks and dominates? What other measures might you look at? Maybe measures of bifurcation, how many different groups are there that kind of are talking, things like that. And so you feed all of those into a regression model. That's one version. There's also, you might look at individuals and look at, maybe even looking at, whether they're elected again or something based on their centrality in the Senate network.
Okay, interesting. Fascinating, because I mean we're talking, in political science and also in communication about power and influence, and this is a tool that sort of reveals that in different ways that you might not see by looking just at the video.
I think that's exactly right. Yeah, that's a really nice summary.
Okay. Any other questions, Andrea or Medea or Christina or Caitlin? Don't want to cut anybody off, but we don't want to just.
No, I don't have any questions.
Okay. You can reach Jeremy. It shouldn't say Jeremy there at JD Foote at Purdue. And if you have ideas on other workshops that you want to have, and we can drill down into this one more in the future too, as we get some more real data to look at. It would be very interesting. There's, for any graduate students, would be fascinating papers. And I would encourage you to talk to me or talk to Jeremy, and you have the ideas and we can help you with the data and the analysis. So that's the way that academic research works. So I'd like to thank everybody for being with us. We'll have more sessions next year. And thank you so much, Jeremy.
Yep. Thank you. Thank you. Very nice to be here.